Alright, in this video we will define center of mass. So the center of mass, this relates a lot to as we get into the chapters 9 and 10 with torque and rotational motion. This leads into that quite a bit. But the center of mass is it's a weighted average, a mass weighted average of all the individual pieces. The important thing about the center of mass is that it's like the point where we can consider, we have some mass shown over here in this figure. This is actually just two different views of the same mass. The center of its mass is kind of, if we were to, obviously this is not just a point mass, meaning that it has an infinitely small size. There's clearly some size to it, but if we were to consider all the mass acting at one point, it would act at its center, at the center of mass. And so there's some mass over here, but then there's some mass over here, and halfway between these, essentially halfway between these, is right here. And so we kind of do this with all the little pieces of mass, and we get the center of mass here. Now, to find the center of mass of a complex shape like this will require some techniques from calculus, and so we'll have much simpler center of masses that we deal with, but this is the concept. So effectively, we could treat all the mass as acting at just this point. So if I were to try to balance this, if I were to push up on it, then if I had to push up at this point, then I would have my net force would be equal to 0 on it, and no rotation would be caused. So effectively, kind of maybe this elephant picture over here might show a little bit of a better example. The center of mass of this elephant is right here at this red circle with a blue cross through it. The center of mass is straight down like this, or the center mass is there, so gravity acts down at that. In reality, gravity acts down a little bit on its toenail over here, and the nose and the tail and whatnot, but it effectively all acts at this one point at the center. And because the elephant is positioned right above this, then the elephant will be able to be stable, because it has positioned itself right over its center of mass. We'll get into this in a lot more detail when we talk about torque, but this is the importance of the center of mass. So to calculate the center of mass, it's just a mass weighted average. So what I mean by that is we take, like in this example, say we have three masses, 3 point masses. So these, what I mean by a point mass is that it has absolutely no size. So mass 1 has no size, or it's all located at a point, but it does have a mass. So it's a point mass. And in order to find the center of mass, we again break it into components. So we find our x coordinate of the center of mass is the x center of mass, and this is the x coordinate of mass 1 times the actual mass of point 1, plus the x coordinate of point 2 times the mass of object 2, plus the x coordinate of 3 times the mass of 3, plus, if I have infinite more of these, I could add them all up. And then this is then divided by the total mass. So mass 1 plus mass 2 plus mass 3 plus yada yada yada. Okay. So it's a weighted average. Now you would expect here, if mass 2 was 1 kilogram, mass 3 was 1 kilogram, and mass 1 was 1,000,000 kilograms, you would expect effectively all the mass to be located at mass 1. Okay, so this is why we have to weight the coordinate of 1 with the mass of 1. So because it's 1,000,000 kilograms, it plays a much bigger role than mass 2, which is 1, and mass 3, which is 1. So this is the purpose of multiplying by the mass. And then when we divide by all these masses, we're renormalizing it. We have to we factor out all these masses, so we're just left with the x coordinate. This would be units in meters, kilograms. So we'd have meters, kilograms on the top. We would have So meters, kilograms on the top, and then divide by kilograms on the bottom. The kilograms would cancel and we'd just be left with meters. So let's do a little example. Let's say that mass 1 is actually a little bit smaller here, so let's say that it is 5 kilograms. And then let's say that mass 2, we'll just say that mass 2 is 6 kilograms, and mass 3 is equal to 7 kilograms. So to find the x center of mass of this, we would just take, well, the coordinate of point 1, which is, this is located, or coordinate of mass 1, this is located at the origin, so we have 0 times 5, plus the x coordinate of point 2 is 2, times the mass of, we said 6 kilograms, plus the x coordinate of point 3 was 1, times the mass of 7 kilograms, and then we divide by the total mass. Make sure, although the location of mass 1 was at 0, it's still, that mass still has to be included in the total mass at the bottom. Otherwise, we're not including it. So this is divided by 5 plus 6 plus 7. So this is equal to 19 divided by 18. And our x center of mass is 1.056 meters. And then the same thing with the y center of mass. For the y center of mass, we do exactly the same, except we use the y coordinate. So this would be y1 m1 plus y2 m2 plus y3 m3 plus yada 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 if we have more, divided by just the sum of all the masses. So the y center of mass for this one is going to be, we had mass 1, or the y coordinate of mass 1 was 0. So this is 0 times 5, plus the y coordinate of point 2 was 1, and the mass of 2 was 6. So plus 1 times 6, plus the y coordinate of point 3, which was 2, times the mass of 3, which was 7. So plus 2 times 7, divided by the total mass, which was the same as the total mass we had previously. So this is just 18. So this is equal to 20 over 18, or 1.11 meters. So then our total center of mass, so center of mass is equal to, we write this as an ordered pair, or if we had in 3 dimensions, we could write it as an ordered triple. The x coordinate was 1.056, the y coordinate was 1.11, so this is 1.056 and 1.111, just to keep the same degree of accuracy, meters. So this is our center mass. So it's just a weighted average. This is the same way that your GPA is calculated. It's your grade in one class times the number of credits. You can do that with all your classes, then divide by the number of credits. So center mass. So the general formula is x center mass is this, and y center mass is the same thing, just using the y coordinates.